Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Blue Origin New Glenn Mark II. So let's dive deep into it. So what is this puppy, New Glenn? Well, this is a heavy lift launch vehicle, 45 ton to low Earth orbit. And at this point in time, practically speaking, this is the heaviest active rocket. As in, if you take money, launch something heavy, you're like, isn't Falcon Heavy supposed to be heaviest? Yes and no. Yes, on paper and in actual thrust tons, it has the oomph to send a 60-ton object. It's just that does not have the second stage built for that loading. So if you actually pay them, they're like, bro, we have to charge you extra and we have to redesign a second stage that can handle that. So what's the use of it? It's generally utilized for high delta V, meaning if you have a satellite that is not 60 ton, but it needs to be sent to a, let's say, geostationary orbit or some sort of interplanetary orbit where you need bonkers delta V. That's how you achieve it. You reduce your tonnage, increase your velocity. This puppy, it's big, it's powerful, and let them be clear, this was before SpaceX became successful, so it was very old design philosophy and all that, but it was big. It was not as big as Saturn V, but it was big, and people are like, whoa, this is big. And two-stage liquid propellant system, and again, much better design compared to ULA's we have a tiny rocket, and what if we strap shit to it? It's like, what if you make a bigger rocket? So this has methane for base stage. Why methane? Because it's cheaper. Liquid hydrogen for upper stage. Why? Because it gives you better delta V. So for gravity fighting, where it's like oomph, you need oomph, methane gives you that oomph. And when you need the speed, the velocity for delta V, high velocity injections, for that puppy, hydrogen is the best. So it is taking the best. It's almost like Saturn V, where Saturn V used kerosene for the lower stage, as in jet propellant number 1, where it needed the oomph. And for higher velocity, like lunar injection burn, it was like hydrogen, baby. So it is doing the same philosophy. Yes, it does come with a complication, like your cost goes up and hassle and messel, but it does give you that power. And that it also has 2 hydrogen powered engine. Now, if they were methane powered, there is a very good chance they could have done it with 1 engine, but it will not have the specific impulse. So with hydrogen, you get the specific impulse, but you do not get the thrust. So how do you compensate? Put 2 of them. So that's how they're doing it. And their delta V is genuinely good. They can dump 13 ton to geostationary transfer orbit. That's good. Now, why is that? Well, it was designed for military's contracts from day one. Basically, they were targeting ULA. Like, okay, what was Falcon 9 contract? Falcon 9 was designed as a commercial resupply mission. So their target was low Earth orbit, specifically ISS. Take a puppy, dump it into ISS. That's what we're getting paid for. The whole rocket was designed around that. And of course, once they built it, once they finalized it, V1 model, and they started to get the contract, then they started to refine it. So it, got sold. This was designed on a different philosophy. It was it was a big thing. It was not just get into it. It was like, no, I have the money, I have the time, I have the patience. Let's just build one big puppy. Reusable booster, it also has that, and it is very shocking given the fact apparently the Falcon 9 first landing was in 2015. I was in Bangalore doing game artist at that point in time. So it's a big deal that everybody looked into it, everybody realized how big of a deal it is, and nobody, 10 years have passed, nobody is like, okay, this is our rocket that does it. There are a lot of startups, but none of them this is our rocket, this is going into orbit and we are recovering it. That's not done yet. This becomes the second system that does that. That's big. And it gone through massive delay. Basically, it's lol, as in they do have the idea of brick by brick, day by day, but it's actually taking brick by brick, day by day. So the delay was very massive, and the first launch finally happened on 13 January 2025. So they were late, but it did do everything in orbit. Basically, as a rocket, the system was cleared in first go. They launched the puppy, it went exactly, staging happened, it went into orbit, and it also did relight. You must have seen, basically, if I'm not mistaken, IFT number 8 and 10, they were trying to do relights, because sometimes you want elliptical orbit for high energy insertion, you do need to turn your puppy off, as in chill, off. Now turning off, super easy. Reigniting it in space in 0G environment, that's difficult. So they achieved that in one go. So that was done. And they deployed the blue ring payload, this puppy. Now okay, it looks like a very small thing. Yeah, it's designed as a semi-truck on top of a truck. So this is the truck, they're gonna have the semi-truck on top of it. The idea is this main truck will deploy you into orbit, and the semi-truck will deploy into exact orbit that you are looking for. It will have its own solar panel, it will have its own communication system, and it can do a lot of precise maneuvering in orbit to get you where you want to go. I want this sun synchronous orbit, yo, go. I want this inclination orbit, yo, go. So that was the intent of it. They launched it. Now, it's a bit lightweight compared to Falcon Heavy is having Tesla Rooster going there, but it is far more practical, as in like, tada, it's what they're going to deploy. It's what they call Blue Ring Pathfinder. They did fail to land on the ship. Basically, once this puppy returned, it did not reignite. That's why I say turning off engine, GG. Turning it on is difficult. So they failed to turn on. So it kaput. It went kaput. But it did work. Everything from a rocket point of view, it works. Like if there were a company was like, okay, I want to pay a payload for this, they'll be fine. It's like, yeah, who cares about landing? It's like the main thing is I'm paying you money to deploy my stuff in orbit. What you do afterward, that's on you. So New Glenn, first launch was not that great, but it was amazing given the fact that it got to orbit in one go. One go, let that sink in. I made it, I launched it, it worked. And be mindful, that's exact same path as Falcon Heavy. It also failed in the landing. The side boosters were like kaput. I saw that in live. So it's same level. Now we talk about Esplanade, Escapade. This is Escape and Plasma Acceleration and Dynamic Explorer. So this is second paid mission. Let that sink in. This puppy is paid. So it's a Mars mission, and this is the first time NASA is sending twin craft, aka one spacecraft cloned Control C, Control V. Why? Well, the idea is they want to orbit Mars, and they want to study how Sun is roasting the basically atmosphere. Now be mindful, that happens on Earth also. Earth is also losing its atmosphere, but our gravity is strong enough and our composition is good for us, so we are happy here. But Mars has like lost it. But you have to understand like how did that process happen. So right now we have like a lot of instrument in orbit, but they are like very random. It's like, oh, this has this one instrument that can help with that. This is made for that only, as in solar wind interaction with atmosphere, rarefied atmosphere. That's the only thing it focuses on. Why there are two of them? So it can give, let's say, assume this is your planet. It's going like this. Cool, awesome. That's all you get is 1 point data. But if you have two, you can chase it. Basically, what happens at this point, right now, cool. 10 minutes from now, cool. So that data, that flexibility, because again, you might be like, hey, wouldn't that orbit come up in, let's say, after 30 minutes or 60 minutes? Cool, awesome. But here, see, that gives you the minimum limit. If your orbit is there, you have only one craft, that gives you minimum. If you want like very high precision, like, sampling, you do need to shrink your time. Two of them allows you to shrink the time, and it also allows you to increase the time. So they can change the orbit in such a way that it goes through the same point, but after 2 hours. So that allows them to have much better sampling, and that will allow them to have more volumetric analysis of how the heck solar wind is making love to rarefied atmosphere of carbon dioxide. That's what they're doing. And this puppy will arrive on Mars in September 2027. Not that far ago, so to say. And this time, this whole thing is under NASA's low budget contract classified as small innovative missions for planetary exploration. Basically, get it done for cheap. And the craft was made by Rocket Lab. Now, the reason for this is Rocket Lab wanted to do it by themselves, but they need to build the experience. They are using this to build the experience, and after a while, hopefully, their neutron rocket should be able to do this sort of mission on their own. They should not require anything else. So, and this time they are doing something very unique, which is what we call a kidney bean orbit. And you're like, what the hell is this kidney bean? Problem is, when you have a small team, money is very what you call proportional, as in you do not have the luxury. Let's say you built it and it took 1 month extra, now you have to wait 2 years. That's a very big deal for a small startup company, and it's like you do not want to do that. It would be better for you to just put it in orbit, park it in orbit. So this is the idea, park it in orbit without losing the delta V. So they go into orbit, go through a Lagrange point, and because these Lagrange points are acting as like a pivot point, so to say, or gravitational well, so it's allowing you to curve it. So you maintain your velocity, and when you like that window of basically mass transfer window appears, then you go deep into Earth's gravitational well, get the final velocity boost and all that, and then ta-da! So this allows them to be A, launch whenever you want to launch, and B, go to Mars whenever it's perfectly optimal. You do not have to worry, oh, we had weather delay and all that. None of that. Launch when you are ready. So that's a very unique way, and this also allows them the luxury of going through Earth's tail, as in like Earth is there, Earth's atmosphere, whoosh, Sun is going whoosh. So in this, when it's going through that point, it's sampling that data, and when it's going through here, it's sampling the data again. So they are getting very good volumetric data. Basically, that's helping them calibrate, and also adding data how Earth's atmosphere is reacting. While our gravity is strong, it's not infinite. So all that data will help them. So really clever. Like, this is a clever approach, although I have no idea who was mad enough to calculate the orbits, but somebody was. So this is how they are do with Esplanade. So let's understand New Glenn 2. I have to say the best name I've seen. Never tell me the odds. Like Falcon 9 is named after Han Solo's ship. This is literally Han Solo's dialogue. Never tell me the odds. I'm pretty sure somebody else would have said it, but that's how it's popular. And damn. It's launched from Launch Complex 36 on 13th November. And that gives you a gap between Mark 1 and Mark 2, 300 days. It almost took 9 months of delivery to get that. And there was a lot of hold. I'm not joking. I literally was ready to go, hey, I'm going to watch this and live and all that. It's like, no, scrub. And then second time also happened. It's like, oh, I'm going to watch it. No, scrub. Third time it actually went. And they got $20 million paid from NASA to do this. Now, is that a big deal? Actually, yes, because there is a risk. While Jeff Bezos has deep enough pocket where it's like, bro, I can do this on the side, like I can do this all day, is that if they did that, they will never get government contract. They can only get private contract. Because again, if government did that, that will come under a clause of competition. As in like, while legally you should not be allowed to create a loss leading product. Because if you do that, like let's say you're a big company and you're creating a small niche item in a niche market, you can kaput all competition, and once all the competition are, then you can increase the price. So people have learned it the hard way, that it's almost like, venture capitalists will come in, they'll create a service that is just money burning party. But why they are money burning? Because once they kaput all the what you call competition, there is no other option. At that point they will jack up the price and recover all the loss. So that is illegal. So Blue Origin cannot just have the luxury, oh, it's Jeff Bezos money. No, they have to show that they are making some profit from rockets. Otherwise, they will lose a lot of contracts. And again, legal battle and all that. So it's better for them. You're like, okay, but it would have required like say hundreds of million. It's 20 million is above a 20 million, as in $0 or 20 million. 20 million is 20 million above zero. Shut up, take money. So they need that money just to show that it's not that like, we're just throwing money away. We are developing it and we have to recuperate the cost. The booster, this puppy was 603 kilometers away. It's kind of far from basically the base, named after Jeff Bezos' mom, Jacqueline. Big puppy. This is big. Let that be very clear. This is big. People have no context of it, like how huge this puppy is. It's huge. It's not big. It's huge. So what was the result? Well, the result was what we classify as smooth operation. That's the one word to describe as smooth operation. Like if you do not know about enough space systems and all that, you will think you are just watching something like SpaceX. It is so normal. Rocket launched, it worked. Rocket staging, it worked. Fairing separation, it worked. Payload deployment, it worked. Reignition worked. Landing, it worked. Everything was smooth. But it took time. Like, let us be very clear. At this point in time, most analysis suggest that the rocket is still too heavy or engines may be too conservative. We do not. And again, it does make sense. ULA can go YOLO on the engines because it's not a recoverable system. They do not have the luxury. They might want to keep the throttle gentle, so to say. Or maybe this is the first few times and the payloads are so lightweight. They're like, hey, let's just make sure things work. Then we're gonna go. So that's why it takes too long to catch up the speed, so to say. Second stage, they deploy, and be mindful, it gives you more vibe that Falcon 9 is doing it much faster, like much faster. So why they can do it? Why can they still launch something? Well, because of these puppy, two of them. Because first stage is not giving you enough kick. Your second stage has to do heavier work. But thankfully, you are outside of the atmosphere. Thankfully, you have two engines. Thankfully, those are hydrogen engines. So you have efficiency, two of them. Now you can compensate for it, and it does work. And they landed. Now, this is the part where you get the idea of patience. Basically, Jeff Bezos have already experienced, as in the Blue Origin already has experience with landing a rocket. And they always hover. That hovering is something they have fine-tuned. Basically, their engineers are like, oh, this is how we do the PLC loop. Done, bro. Take it and go. They're good. They're good. They got this. So what they do with this ship is like they always come on the side. The idea is if something bad happens, they kaput the rocket, not kaput the ship. Because if ship and rocket both gets kaput at the same time, it would be very expensive. Like, see, that's why it's Tokyo drifting. It's literally on the side. It's designed that way. It's not like SpaceX hover slam. It's like, it has time. It's like it takes its sweet time. Benefit, if something bad happens, rocket goes into the water. If something bad does not happen, then they can park it on the ship. Everything would be safe. So they're reducing the oops margin to very tiny level. It's like, oops should not be like, oh, we kaput here, now we're still crashing with, no. Like, now we are landing. So that oops margin is very low. And to give you a context, like how big of a deal that is that they have that much experience with rocket landing. Yeah, SpaceX took 5 tries for orbital class booster landing. They did it in second. They did it in second. Let that sink in. It's like first time, oh, this did not work. Second time, done. Go home. That is big. Like you might be like, oh, they are late, which they are. There is no discussion about it. But god damn, they are making up speed. And it's not like SLS where it's like, oh, we build SLS number 1, but we do not have the pipeline sorted. That's what they were working on. And every interview with Jeff Bezos is like, it's not the rocket. Rocket is the easy part. It's the supply line, basically the infrastructure, so we can maintain the cadence. And all the people who has interviews, has inside photos, they're like, yeah, a lot of them are ready. Like tanks are ready, rocket engines are ready. They're like, go, 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 go. Once they keep sorting the pipeline out, they should be able to launch maybe as high as 6 launches next year. That should be doable. That's how the hardware rich they should become in 1-2 months. So it worked. Like rocket engine worked. Like the Tokyo drifting landing, launch, everything was smooth. Like just go. Like NASA is like, I did not burn $20 million. So what can we expect in the future? Well, this is a big deal because again, even though 10 years have passed, like, damn, I'm old and I've seen that. So still there is no company. There is no Honda that has a rocket. There is no China that has a rocket, nothing. Even Neutron is still behind schedule. Behind schedule or what? Like, I think it will still take its sweet time. So we are in a position where it's like, nobody is ready where they're like, oh, we have a rocket. Now like, oh, it's older, but again, they're the only one who has there. It's like, yeah, Falcon 9 and Blue Origin. So that's a very big system. And be mindful, bigger payload fairing and more tonnage capacity. So it is unique offering at this point in time. And if you're like, hey, I need geostationary, it is shut up, take money. So that is there. And their engines are already sorted because they have already launched an engine on basically ULA's rocket. That's extra flex. It's like, yo, my competitor, use my engine so we can get all the data. So that's good. And be mindful, none of the engine kaput themselves. Like solid booster kaputed it. Engines did not. So that's a very good, what you call, credibility building. And booster landing was done. And after that, they did explosive welding. Basically, this boom, 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 you are saying, there is like a nail that they are drilling into the metal sheet. And I'm like, okay, isn't that damaging? No, it will not damage the craft. And if they are expecting this, and again, they patented it 1 or 2 years ago, patent is available on Google, most likely they would have designed for it. It's like, oh, we're gonna do this, how do we manage it? Most likely it would be like they have to grind part off from the leg. It would be more cost effective to grind the leg away because you have to refurbish it every time anyway. So grind that away and the plank will be more or less the same. So that is there. And they do have a robot like that. There is a robot that comes in, plugs it into it, plumps basically high pressure nitrogen. There's a lot of nitrogen canister into this. That's the reason, to save the rocket so people can actually go there. So it does that. And there are other robots also under construction and under use. So that robot they showed, like there are footage of it where it comes in and just like flushes the system. So they land it, they booster lock to themselves, and their third time, this is time where Jeff Bezos is flexing now, where it's like, yeah, we're gonna do moon landing. Damn. It's literally like watching Soviet Union and USA going at it again. It's literally like SpaceX feels like Soviet Union was like, we did the first, and America is like, kaput, moon. So that's the hilarious thing. Like, it could happen. That's the shocking part to hear. Like, it could happen. You're like, oh, okay, can they actually guarantee the landing of this? No, of course not. But they have been working on it. And given the fact that they have lot of experience, like lot of hovering experience and years of experience, and the fact that they got landing of this puppy in second go, that means if as long as their radar and LiDAR works, they should be able to land on moon. If they crack that, like first launching it in January 2026, I'm like, that is bold. Let that be very clear. That even claiming that is bold. Let's just see whether that happens or not. Second, landing on moon. Actually doing that, like I landed on the moon, my puppy is on the moon. That would be like, yeah, you can keep talking, oh, Starship, this, like it's just going boom. It's like, it's on 11th try because all the previous tries have failed. Like if it was not Elon Musk, everybody would have been calling it a scam, because imagine it this way, Boeing, I will make a rocket. People are like, awesome. Take money. How much tonnage in orbit? 100 ton or 150 ton. Cool, awesome. They're like, okay, build it. You build it and it's like, yeah, it's 15 ton to low Earth orbit. What will you say? It's like, dude, this is just a scam. It's like, no, we're refining it. Okay, cool. Second version. What is it? 35 ton. Now they are saying V3 should be 100 ton. It's like, can it be? Like, again, it could be, because most likely the biggest issue they have, like the original design was carbon fiber, interplanetary transport, big diameter. So they had a lot of benefit working there. They lost all the benefit when they shrink the diameter, and all the remaining benefit they lost the moment they jumped from carbon fiber to basically stainless steel. It's not working. That's why engine keeps going boom. They are pushing engine too hard. And again, compare this to Blue Origin. Blue is like, we have an engine, we launch, we got everything sorted, then we're gonna upgrade it. And again, that's the exact same thing Falcon 1 did, Falcon 9 did. They have an engine, get it sorted, then work on it. You do not like, okay, oh, it's not working, let me work on the engine. That means engine is not sorted or the vehicle is not sorted. So having lower performance is not an issue as long as if your promise was reasonable. If your promise was 100 ton and now you're delivering 15, ooh. And again, this idea, I have no idea how the heck, who was like taking corruption charges. There's like 22 refuels, and it will require, which mind you, it's a new news to me that apparently there has to be a ship whose whole job is to take all the fuel. Then that ship will dump the fuel into the lunar starship. Just use a third stage, man. So this could happen. Like, let that be very clear. If Blue Origin lands on moon, I could easily see that they can sort out moon. Of course, it will not be very big or magnificent. It will be just like, it's a thing, it works. And again, America would love that because again, that gives them freedom from China. It's like, hey, we're good, we got this. And if SpaceX is delayed, they're like, okay, once you come, you have hundreds of tons. Cool, awesome. Let's hope you do. But again, 22 refueling, doubtful. But this is good. Like, this is a race where USA wins either way. If Blue Origin sorts everything out, awesome. If SpaceX sorts everything out, which again, they can sort it out. They can have brain, or China can have a brain where it's like, hey, let's Control-C, Control-V Starship and just throw away stainless steel, go to lithium aluminum alloy, saves a lot of weight. And instead of that weird hexagonal tile drilling system, just glue it. We've been doing that for centuries. Not centuries, like the oldest is a Soyuz capsule. It still works. Like never ever in case of human space flights we had an issue, tile failed. The only time it happened was space shuttle where a freaking foam block fired a missile into it, going at super speed, as in Mach speed. Any object that is traveling at Mach speed, even if it's as low as like 2 kilograms, yeah, that's gonna punch a hole. It does not, I don't even think even stainless steel will be able to handle it. So again, this whole idea, we want it to be easy. Just robotize it if you want it to be easy. So let's see what happens. But damn, this is going to be interesting. Like, Americans are right now, it's like flexing. It's like, oh, bro, we got 2 companies. Everybody's like, we're going to do reusable rocket. We have to reusable rocket. That's a big thing. So paste your comment down below. Do you think this puppy will land on the moon? And when do you think they will launch it? I don't think January 2026, maybe February, but let's see. So this was my presentation on basically Blue Origin New Glenn Mark II. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.